easily solve. If you understand decision tree is very simple, we can solve the problems based on the decision tree. Good morning, students. Welcome to this session. In this session, we will start with the fourth module, and in the fourth module, we will start with the decision trees. So, decision trees are very important. Then decision trees are very simple way to guide one's path to particular decision. Uh, Decision trees are one of the most widely used techniques for classification. So we can use decision tree for the classification problem. It could be a binary class or the multi-class. Classification technique is a technique of grouping or categorizing or bucketing the data points. You can say anything. Grouping, the classing. Okay, classification is what you are putting the data points into different classes. Okay, if it is two classes, it is a binary class. If there are more than two classes, it is a multi-class problem. Or you can say those are groupings or categorizing or bucketing. So you are putting the data points into different buckets. For example, banks would be interested in predicting the loan defaulter, which is an example of a binary classification. So, bank, they would like to see whenever there is a new request for the loan by a customer, they want to, based on certain attributes of that customers, based on the certain data of the customer, they want to classify that particular consumer as a potential defaulter or not, yes or no. If it the outcome comes as the S, then potentially the bank will deny the loan to that particular person. If the result comes as potential defaulter as no, then bank would be interested in further pursuing with that particular consumer to provide the loan. Then a multi-class example is news mining, which classifies news into sports, politics, technology, entertainment, etc., which is an example of a multi-class problem. Suppose, let us say your algorithm, you are mining the news. Okay, based on the whatever the news mining you are doing, you want to classify that particular news article into different classes. So either it is a sports news, political news, technology related news, or the entertainment related news, or any some other category that you want to classify. So that is an example of a multi-class problem. Decision trees are a simple way to guide one's path to a decision. So why we use the decision tree? The decision tree will help us to make the decision. What is the decision? Either binary class or the multi-class. Decision trees are hierarchically branched structures that help to arrive at a decision based on asking certain questions in a particular sequence. So, what are decision trees? It is a hierarchical branch. It is structured so that there will be a question asked at each of the node, and according to the answer to that question, the particular flow will go down the tree, and which will go to the particular end leaf where we have the particular class or the decision. A good decision tree should be short and ask only few meaningful questions. So this is the most desired out of the decision trees. It should ask very few questions, very short questions, and it could arrive at a meaningful decision. Decision tree models can be trained using the training data. For training the decision tree, we need a training data. And what is a training data? Training data is the data where we have the all the elements of the data, and along with the decision. Decision is nothing but the class. So, for example, for the defaulters, for the bank's problem to find the defaulters of the loan, we should have a historical data where we had the defaulters and non-defaulters, all the data, the factual data that will be our training data, that will be the input for building our model. Based on that training data, we will build the model, decision tree model, and that model can be, based on how much accurate it is, that can be used for the actual production usage. The trained model can be used on the test data for the classification. So normal, how you do, you first use the training data, and you come up at a with a optimum decision tree model. Once you are satisfied with your decision tree model, let us say on training data you are getting a accuracy more than 80% or more than 90%, then you think it is a good enough accuracy, then you will test that model on the test data. Okay, and what is the test data? The given historical data is broken into two sections. Maybe it is in the ratio of 70 to 30 or 80 to 20. 80% of the that data would be the set as the training data, which is used for the training the model, training and building the model, and rest 20 or the 30% of the data is kept for the testing of that particular data. So that rest 20 or the 30% data is not seen by the model before. So when we give that data and when we see its prediction capability, then we will come up with the accuracy. On the test data, what would be the accuracy? If the accuracy on the test data is also like more than 80% or the 90%, then we can say that is a good model. The accuracy of the model depends on various factors such as complexity of the model, size of the training data, etc. So accuracy will depend on lot many factors. If we have more training data, we can build up better models, and also how much complex is our model. Okay, how many parameters are there which are part of that decision tree, that will also result in the complexity, and which will have an impact on the accuracy of that particular decision tree. And we have the one example caselet, predicting of heart attacks using the decision trees. This is the study done by the University of California, San Diego, concerning the heart disease patients data. The patients were diagnosed with heart attack from the chest pain, diagnosed by EKG, high enzyme levels in their heart muscles, and so on. So here the objective of the building the model is predict which of these patient was at a risk of having a second heart attack within the next 30 days. So after this diagnosis, they want to see like in next 30 days out of these patients, how many will have the second heart attack, so that that data will be useful in further diagnosis. The prediction would determine the treatment plan, such as whether to keep the patient in intensive care or not. For each patient, more than 100 variables were collected. So you can see here the number of variables collected. Variables is what? These are the entities on which the decision is made. So there are 100 variables for each of these patients that were collected, including demographics, medical history, and lab data, including everything. There were more than 100 variables. Using that data and the CART algorithm, decision tree was constructed. So the next page shows the decision tree. So this is the example of the decision tree where each node we have a questions, and based on the answer to the question, the tree will drill down. For example, BP less than or equal to 90. Then if answer is yes, then there is a high risk. That is a high 70% of having a second heart attack. If the answer is no, the next question is age less than or equal to 62? If answer is less, then there is a low risk, that is 98%. That means there is probably there will not be any heart attack in the next 30 days. If age is more than 62, then has sinus problem, yes, there is a 50 chance of having a high risk. And if it is answer is no, there is a very low risk, that is a 89%. So this is the decision tree. And using this particular tree, this predicted around 86 point of the 86.5% of the cases correctly. Means its accuracy was 86.5 in production, that is in reality. Decision tree problem. Imagine a conversation between doctor and a patient. So how the decision trees are evolved. Decision trees are very intuitive, means this is based on the kind of analysis an expert would do. For example, a doctor, whenever a patient goes, the kind of questions the doctor will ask the patient, and starting with a very important question, okay, then ending, based on the answer, he will frame his questions differently. So that kind of a conversation is nothing but it is like a decision tree, where doctor will ask the questions continuously to the patients with a very high important questions, and based on the answers he will ask some other questions, and so that he can come at a some reasonable decision to what might have happened to that particular patient, and he will be able to diagnose that particular patient. Another example, this is how expert in the any field solve the problem. They use the decision trees or decision rule for every questions they ask. The potential answers create a separate branches for further questioning. For each branch, the expert would know how to proceed ahead. The process continues until the end of the tree is reached, which means the leaf node is reached. Leaf node is a end where we have the decision, okay, decision or the class, whatever you want to call. So this is how the questions will be continuously asked, and it will accordingly it will be branched, and that branching will not stop until a final leaf node or the final decision is made. Human experts learn from past experiences of our data points. Similarly, machine can be trained to learn from the past data points and extract some knowledge or rules from it. So, as we do the humans, this is a natural tendency of the human, how we make the decisions. The same thing can be incorporated into the machine learning scripts, where by which they can make a decision based on such a model. A decision tree would have a predictive accuracy, and it depends on the training data. So if there is a large amount of training data that is available for the decision trees, then that kind of a decision it will make is very highly accurate. More training data is provided, the more accurate its knowledge extraction will be, and thus it will make more accurate decisions. More variables. So in the previous case, we saw like there were more than 100 variables. So if number of variables which are very decisive, okay, there should not be redundant variables. If those 100, whatever the number of variables we have, are more decisive in making the decision, if we have more number of such variables, that will result in a very high accurate system. So accuracy will be very high. In addition, good decision tree should also be frugal, so that it takes the least number of questions, and thus the least amount of effort to get to the right decision. So when we are having large amount of data, so that will help for training our model. More variables, it is very helpful for, excuse me, for having more decisive points, which will be result in a very accurate decisions. At the same time, it will also make it as a more complex, more number of variables, so that we should have a reasonable, that is the frugal amount of questions, and frugal amount of the branches, where we the tree will spend least amount of effort in giving the right kind of a decisions. So it depends on what kind of questions are framed, how you are able to put the very important questions at the top, which will have a mutually exclusive data, and which will result into the decision with a narrower path. We have one decision tree example. In this decision tree, we are going to solve this decision tree example, and we will use the how we build the tree, how to decide to build the a particular root node, and once we have the root node, how we will decide to have a additional branch nodes, how to split All those will be learning with this particular example. Here is an exercise. Create a decision tree that helps make the decision about approving the play of an outdoor game. The objective is to predict the play decision, play or not. Okay, given the atmospheric condition out there. Decision is should the game be allowed or not. So what decision we are making here? Whether we should allow the game to go on or not, play or not. So here are the different parameters, four parameters. They have given the outlook. Outlook is sunny, temperature is hot, humidity is normal, windy, true. It is windy. Based on these four factors, we have to make a decision whether the play is yes or no. So this is the outdoor game. So whether we can allow the outdoor game to happen or not. So we have to make this decision. And to answer this question, we have to have the historical data, past data. Based on that, we will we'll build a model, and on top of the model, we apply this rule. Okay, when we apply this rule, we will come to know what is the answer. To answer that question, one should look at the past experience and see what decision was made in similar instance. If lookup table has a similar question, then we can get the answer. So lookup table is like we have a historical data, and there is a certain data element or the certain data which exactly match this one. And outlook is sunny, temperature is hot, humidity is normal, windy is true. And whatever the decision that was made on in the history, the same can be used here. That is using the lookup. If you are using the lookup, it is like you are running a select query. You are saying where outlook is sunny, temperature is hot, humidity is normal, and windy is true, and you are getting what is the value of the play. So if that value is available, then we can use the lookup table. If it is not available, lookup table will not be able to make the decision. And there are certain disadvantages that are associated with the lookup table. These are the disadvantages of the lookup table. Lookup table is what? You are just going and seeing in the historical data, and you are matching each of these values. So you are matching each of these values and finding whether this data is available. If that data is available, either yes or no, you will say that is the decision. But the problem is there are many disadvantages of looking up table like that. As mentioned earlier, how to decide if there is not a row that corresponds to the exact situation. What if? So there may not be a matching record. So then what is the decision? We cannot take any kind of a decision if we are using the lookup table. If there is no matching instance available in the database, the past experience cannot guide the decision. That is, so the past experience will not be able to help us with the current question. Searching through the entire past database may be time consuming, right? We don't know how huge is our data, and searching through all that data, it is not a good idea with respect to the performance. It will be very time consuming. Depending upon number of variables and the organization of the database, it will degrade the performance, and it may not yield the good result if you are not able to find the exact record. What if the data values are not available for all the variables? In this instant, if the data for humidity variable was not available, looking up the past data would not help. So if any data variable is not available, then there is no use of looking up the past data, and that will fail in coming into a proper decision. So this is the example. Here we will not use the lookup table, but we will use the decision tree, and this is the data set. We will look into this data set and try to understand, and we will see using this data set how we can build a decision tree and answer the given question. I will see it in the next class.